Today's video is solving quadratics by completing the squares. This is lesson 5.4. The goal today will be to solve a quadratic by creating a perfect square and then using inverse operations to find x. It's important to note that this is a separate method for solving and could be used when a quadratic cannot be factored. And there's lots of quadratics that can't be factored. This is an example of one where the c term is 7 and the numbers that multiply to give us that 7 do not add up to the b term, which is 3. So let's go ahead and get into the key terms today. A couple key ideas. Perfect square. You've seen a lot of these. I'll give you a couple examples what perfect squares look like in a number example and an algebra example. So perfect square in a number example would be 3 squared, because a expression that is times itself twice is what a perfect square is. So 3 squared is being multiplied twice, and then 10 squared, where 10 is being multiplied twice. In algebra, you've seen x squared, where x is being multiplied to itself twice, and we've also seen binomials that are being squared. So x minus 1 squared is also a perfect square, so really anything to the second power. Now the inverse of a square, so if you're going to solve, try to find what something equals that has a square in it, you're going to need a way of getting rid of the square. So the inverse of a square is a square root. What a square root does, it reduces the power of whatever you're square rooting by 1. So if we're going to solve x squared equals 9, we're trying to find what number squared equals 9. So you're probably already thinking, okay, I already know that the number squared that equals 9 is 3. You already know that x equals 3. However, I'll caution you to thinking that that is your only answer. Right now what we have is something that's being squared. And we know that if x is to the second power, then there should be 2 solutions to it. And there absolutely are. So yes, x equals 3 is one of those 2 solutions. So let's figure out what happens and how do we find the second solution. So if I'm going to solve this using inverse operations, what I'm going to have to do is I'm going to have to square root this square. And if I square root one side, obviously I have to square root the other side. This now reduces the power of x to 1. So now we've got x to the first power, which is x, equals, and in front of this square root, what you have to remember to include, and this is very, very important, common mistake that you always forget this, is a plus or minus. This is where our 2 solutions are going to come from. One being the positive and one being a negative. So x equals a plus or minus. And we can go ahead and find the principal root. And the calculator does not find both of them for us. It only finds us the positive or the principal square root of 9. Use the calculator. So here we have the square root of 9, and it's going to give us 3, but it's not just 3, it's plus or minus 3. So x equals a positive 3, and it also equals a negative 3. That's what that plus or minus does. It splits up. It says, okay, there's 2 solutions here. One of them's positive, and one of them's negative. And if you think about it, that's kind of true, because 3 times 3 we know is 9, but we also know that a negative 3 times a negative 3 is a 9. So that's why this plus or minus is very, very important to include as you take the square root of things. So we're going to use both of these ideas as we go through a couple examples today. So our first example is asking us to solve for x, and we're going to use completing the square. And the first thing that you need to do when completing the square is you need to convert the equation so that the x squared term and the x to the first power term are on the same side of the equal sign. And right now you can see that they're on opposite sides. So let's go ahead and use inverse operations to add this 20x to both sides. And now our equation becomes x squared plus 20x equals a negative 91. Now it's not important to have this number be on the same side as these terms. If it is, it's really not a big deal. But it's best just to keep it here, because we're going to have to solve for x eventually, and that saves us some time. Now our second step is to split square and add. So these are 3 things in one. So we're going to half b, we're going to take that, and we're going to square that, and then we're going to add that to the other side. So we're going to split b, we're going to divide it by 2, we're going to drop it into our binomial, so this is like a shortcut way of being able to do this. Half of 20 is 10, and we're going to write it just like this. We just drop that 10 right here. Here's our division of 2, this is our split. Now we're going to square 10, so 10 squared, and we're going to add that to the other side. So 10 squared is 100, and then everything else is the same. So we've got negative 91, and we've added 100 to that side. And you're thinking, why did we add to 100 to one side and not to the other side? Well, real quickly, I'll just draw this little box. This little shortcut method that we created is x plus 10 times x plus 10 times itself. If we were to multiply this out, what we'd get is x squared. X times 10 is 10x. X times 10 is 10x. And 10 times 10 is 100. So inside this binomial, what we did is we added 100. So we had to make sure we added it to the other side. That's what we call split it, square it, and add it. It's a shortcut method. Now what we have is x plus 10 squared equals, go ahead and write this right here. We've got x plus 10 squared equals negative 91 plus 100 is a positive 9. And so we're going to solve using our inverse operations as our final step. So the step that we'd have to do first is to get rid of the square, the power, by square rooting. So we square root this side, and we square root this side. And as I square root this side, I remember I've got to include this plus or minus. That way I know that there's 2 solutions in the end. These reduce to 1, and everything in this parentheses to the power of 1 is just x plus 10 equals plus or minus the square root of 9 is 3. We're going to find the principal square root, and we already actually did that in the previous example, so I'll just write 3. So now what we have is really one equation, but it's actually 2 equations because of this plus or minus. So we're going to go ahead and just continue to solve. We're going to subtract 10. We're going to minus 10 on this side. And now what we have is x equals plus or minus 3 minus 10, which is the same thing as positive 3 minus 10 and negative 3 minus 10. Always make silly mistakes in the video. So we're going to just simplify both of these. So 3 minus 10 is a negative 7, and do not get in the habit of thinking, oh, if this is a negative 7, this is a positive 7. That's not ever going to happen. This plus or minus does not make one answer the same, but with different signs. You've actually kind of got to think about it. Negative 3 minus 10 is a negative 13, and so our final step is to put these in numeric order. So we're going to say negative 13, comma, negative 7, and that is how we get our 2 answers. Split, square, add. Alright, example number 2. I know the first one was kind of long, but it takes a bit to kind of understand this. Our first step here is to get our squared term and our bx term on the same side. This is a negative squared term. We do not want negative squared terms. Easier to deal with positives. So let's go ahead and add this to the same side as our x term. And we have now x squared minus 8x equals a negative 15. Now we've got our square term, our first power term on the same side. We can go ahead and split, square, add. So if we split negative 8, and it's a negative 8, we get a negative 4. So we can say x minus 4 squared equals, now we go ahead and square negative 4 and add it to the other side. So plus 16. And we've got this negative 15. Now we can simplify this equation. Negative 15 plus 16 is a positive 1. So we've got x minus 4 squared equals 1. Now time for solving. We're going to use inverse operations. First, let's go ahead and get rid of the square root, or the square, sorry, with the square root. And we're going to square root this side with the plus or minus. We've got x minus 4 equals plus or minus, and the square root of 1 is 1. And now we've got to add this 4 add this 4. X equals a positive 1 plus 4, and x also equals a negative 1 plus 4. Simplify both of these. 1 plus 4 equals 5. Do not think that this is a negative 5. I know you're going to do it. It's not a negative 5. Negative 1 plus 4 is 3. So these are our two answers in numeric order. 3 is smaller, 5 is larger. That's the order we put them in. That's example number 2. Split, square it, add it. Make sure that you solve it with a square root and a plus or minus sign. Don't stop till you get enough. Okay, now we've got our square term and our x term on the same side with the constant, and it just makes it easier when we only have these two. So I'm going to go ahead and eliminate this constant on this side by adding it. So I really only need the x squared term and the first power term. Those are gone. We've got x squared plus 6x equals a positive 40. And now we can go ahead and start to solve. So let's split the 6. That's 3. It's positive equals 40. 3 squared is a 9. So we're going to say 9. So now we've got x plus 3 squared equals 49. We can solve using our inverse operations to get rid of the square. We've got a square root. We're going to square root and make sure we include the plus or minus. Those are now reduced to 1. We're left with x plus 3 equals plus or minus the square root of 49. We'll use the calculator to help us figure out what the principal square root of 49 is, and it's 7. And so now what we have is minus 3, and we've got x equals plus or minus 7 minus 3. Break up our two little equations. We got positive 7 minus 3, and we've got a negative 7 minus 3, which equals a 4, and which equals not a negative 4, it's a negative 10. Put it in numeric order, negative 10, comma 4. That should be a bracket. Okay, 2 more examples, and they're quite different, much easier examples that you might see. In this example, it's saying fill in the blanks to completing the square. So it gives you this quadratic, and it's saying, okay, fill in the blank here and fill in the blank here. Well, we know that the blank here is the split. So we're going to divide this by 2, drop it in there. Negative 5, or negative 10 divided by 2 is a negative 5. So we'll just say x plus a negative 5. And we know that plus and negative is the same thing as minus, but we'll leave it for the time being. And now we're going to square the negative 5. And it gives us a positive 25. So our blanks that we're filling in are the split and then the square add part. Last example for today. X squared plus 18 equals negative 40. Fill in the blanks. For the split part, divide by 2. Drop that down in there. That's a 9. And square a 9. And it's an 81. And we're done. Anticipate this to be kind of new to you, but the more you do this, the easier it gets, and you'll find out that this may be one of the most efficient algebraic ways of solving a quadratic. Good luck on the problem set.